This section's on 7.2, the circle and the ellipse. So the equations to find the circle and ellipse are exactly the same format. The only difference is when you get to drawing the circle and ellipse, it will be different depending on what your base number is for the denominator. So this is what it's going to look like, the equation. It's going to have the same format of x squared divided by a squared, and then plus y squared divided by b squared is equal to 1. In the book, you may actually see it reversed as well. So they show it as two forms. This is one equation. And then the other equation, they'll show it as x squared divided by b squared plus y squared divided by a squared is equal to 1. They're exactly the same. The only difference is down here, these numbers right here, the denominator, they're going to be the distances that you're going to go. So if they're exactly the same, then obviously it's a circle. And if it's not, then it's going to be an ellipse. And then the ellipse, depending on which side is the larger side, will then be the format of elongated, either on the y-axis or elongated on the x-axis. So that's the difference between that right there. Okay, so now when you do ellipse and also the circle, you need to find certain things. So you need to find is the center, and the center, like the parabola, is going to come off of these guys right here. So like the h and k's that we've been doing. So that's going to be your center. So in this case, obviously there is no h and k, as we learned in last section on the parabola. So that's going to become 0, 0. Now the foci. The foci is the same thing when we did the parabola. We call it the focus. But since the focus, there's only one, and then in the foci, there's actually two. So foci is actually the plural. Now, you may hear it as foci as well, but I like to say it the foci, just because I remember as the eye being, there's two eyes. So I call it the foci. There's two ways to say it. You can say foci or foci, but either way, I go with the foci. Okay, so now the foci, the formula for foci is going to be the c squared is equal to a squared minus b squared. Now again, this depends on the numbers up here. So you would always go with whichever is the largest number. So in the other cases, if b is larger, then obviously you're going to put in b squared minus a squared, and then you're going to take the square root of both sides to find out what the foci is. If you put the b, which is smaller over here, and a that is larger on this side, it's not going to work because you're going to get a negative number on this side, and you can't take a square root of a negative. Okay, so that's important. Now, the foci is also going to be from the center. You're going to count it up on the foci as well. The foci also will be on the longer side. Now, normally foci does not apply to circles because on the circles, all sides from the y's right there and all sides on the x's right here should be the same length, okay? Now the ellipse, they will not be the same length, so that's why it's called the ellipse, because one side, whether it be the y side right here, because it's elongated right here, would be larger or longer than the x-axis, or vice versa. The x-axis is going to be longer than the y-axis right there. Okay, so whatever is the longer side, that's where you're going to go ahead and plot your foci, because it only makes sense. And when we start graphing out, you'll see why. If you try to do it on the short side, it's not going to work. Sometimes it's going to be on the outside of the short side if you do it that way. That's why. And then normally once we get to the foci, whatever the points are right there, the x and y numbers, you're going to have two of them because you're going to have two foci, right? There's two eyes. So you're going to have two of them. So you're going to put the x and the y numbers for that. Okay? And, oh, there's one more, is the vertices. So when we did the parabola, we call it the vertex, with the vertex as being the tip of the parabola. And so when we do ellipse, you'll need vertices. On the circles, you don't do vertices because it's not, it's basically the foci and the vertices come in hand. Okay? So if you don't have a foci, then obviously you don't have vertices. If you have a foci, then you will have vertices, okay? So when you have foci, then whatever the foci may be, so if it's on the y-axis right here, those are your foci, then vertices will be the one on the tip of that right there. Or if it's on the x-axis, your foci is here and your foci is here, then vertices would have to be the tip of that and then the tip of this right here. Okay, it's kind of like if you think of it, two parabolas put together. What the ellipse looks like is two parabolas put together. Because if it's one parabola, you have a focus, right, and a vertex. So those are the two right there. And this the opposite end, you'll have exactly the same. So it's almost like a reflection of on both sides of the parabola is what the ellipse is. Okay, so let's go ahead and do this first example. So example 1. Oh, also let me point out, on the circle and the ellipse, you always want it equal to 1 right here. If it does not equal to 1, you're going to have to force it to equal to 1. So whatever that number is, you're going to divide it out by that number on both of these guys as well. So when we get 36, for example, like this, I can't have a 36. I need to have is a 1. So we're going to divide by 36 on both sides of the equal sign. So here we have is divide by 36, and then divide by 36. Now when you divide by 36, 36 over 36 is equal to 1, which we want. That's why we want to make it that way. And then if you can reduce fraction, most likely you're going to be able to reduce fractions. Now if you can't reduce fraction, most likely something went wrong. So that's when you know you need to check your work. So 4 goes into 36 9 times, so it's going to be y squared on the top all over 9. And then on the bottom is, or on this right here, and then on this one is going to be 9 goes into 36 4 times. So it's going to become 4 right here. Okay? Now, to do the same form that we wanted right here, notice there's a squared and b squared. So I want the same format right there as well. We're going to get rid of the 4 and make it into, basically you're taking the square root of this. So square root of 4 is 2, so it should be 2 squared, because 2 squared should give me 4, so that one works. Plus, and then y squared all over, this is going to be 3 squared, is equal to 1. Okay? Now, if I don't have any numbers inside, then obviously my center is 0, 0, so center 0, 0. So at 0, 0 right here, I put my first dot right there, and then what we're going to do is, on the x-axis right here, the reason why I took it to 2 squared right here is because whatever this length is, that's what we're going to do for the x-axis. So the x-axis, it says a length of 2. So from the center, I'm going to 2 spaces to the left and then 2 spaces to the right. Why is it to the left and the right? Because that's the x-axis right there. Okay? Now, the y-axis, though, I'm going to 3. So from the center again, I'm going 3 spaces. So it's 1, 2, 3, right? We should put little dots right there. And then do the same thing. From the center again, we'll go 1, 2, 3. So that's going to be there right there. Okay? So once I get those dots right there, I should connect them. And then that's going to give me the ellipse format. And again, the reason why this is an ellipse is because the distance on the y and the x's are not the same. If they were exactly the same, it would actually be a circle instead. Okay? Now, once I get to here, then I have to find is if it is an ellipse, I need to find the foci and also the vertices. So the foci, the formula again, was a c squared is equal to a squared minus b squared. So basically whatever side is the longest side. So in our case, 9 is obviously bigger than 4. So we're going to go 9 minus 4, which is equal to 5. So this is your b squared minus a squared, right, is equal to c squared. And then we want to square root it. So square root of 5 is approximately 2 point, what was it, 2 point something? 2.24. So 2.24, 2.24. So from the center again, we want to go 2.24, and it's going to be the longest side. So this is where I'm going to show you. It doesn't work when you go on the x-axis, because on the x-axis, if I'm trying to go 2.24, right, then you're going to go 2.24. Oh, you're on the outside of this. This is why it doesn't work this way. So you always want to go to the longer side. So on the longer side, when you go 2.4 or 2.24, then it's right here. And then doing the same thing from here, 2.24, you're going to be somewhere around here. So that's going to be your foci. And so then obviously the vertices are going to be here, the tip of that, and the tip of this right here is your vertices right there. Okay? So we're going to go ahead and put the coordinates for that. So the foci is going to be then 0 on the x-axis and y of 2.24. So foci should be 0, 2.24, and then the opposite, which is 0 and negative 2.24. Okay? Now vertices is going to be the tips of these guys right here. And remember, the tips right there, we went a distance of 3 right there. So the vertices would then be 0, 3 and 0, negative 3. Okay, that's it. Those are your things that you're going to look for the ellipse right there. Now, this is obviously the simplest form right here when we have something equation like this, but it doesn't always work that way, as we learned. You can do things like this, which then requires the completing of the square. And again, this is why it's so important to do the completing of the square. It all comes down usually as this chapter where we use the completing of the square. So once I use the completing of the square, I will have to determine if this is going to be a circle or an ellipse. Okay? So completing the square states that I want to have all my x's together, all my y's together, and then we're going to bring the number on the other side of the equal sign. So we're going to have is x squared, and let's see, minus 16x, so minus 16x, and I'm going to go ahead and put parentheses, because I'm going to say that's one group, plus, and then this is going to become y squared plus 14y, and then the 32 is going to come to the other side, so it's negative 32 right there. Okay, so now we're going to start doing that completing the square. So we take half of b, so half of 16 is 8, right? So then it's going to become 8 squared right there. So that's one set, plus, and then we take half of 14, which is 7. So 7 squared is equal to negative 32. And remember, this is the tricky part of the completing the square. We always want to put these numbers, the made up numbers, on the other side as well. So since this is 8 squared, I'm going to go ahead and put 8 squared and then also 7 squared. Remember, if it's on the other side of the equal sign, you want to balance the equation. So if it's plus right here, you have to do plus right here as well. But if you put it on the same side of the equal sign, you want to cancel it out. So you would do plus right here and a minus if it's on the same side of the equal sign. You got to make sure you're careful about that. Okay? So now let's go into doing the perfect square. So a perfect square says I write the variable x, I bring the sign from this part, the b part of it, right? And then bring the number, which is 8 squared. And then we do the same thing for the y. So plus, and then the y, we write the variable, the sign is plus, and the number 7 squared is equal to, and then we do the negative 32 plus 64 plus 49, and that should be about 81. So 81. Okay, so again, the form is that we want to always equal to 1 on this side right here. So if we want it equal to 1, we're going to have to divide by 81 on everything. So divided by 81, divided by 81, divided by 81. So this is going to come out to 1 on this side. Perfect. And this is going to become y plus 7 squared over 81. And then on this side will become x minus 8 squared all over 81. Okay, now you can see both of these right here are 81, so obviously this is going to be a circle right here because the numbers are the same. But we still want to go ahead and do the square root of that, so that way when I count it out, it's going to work out for the x-axis being it's going to be 9 squared, right? And then the y-axis is going to become 9 squared as well, equals 1. Okay, so now we're ready. So this is the final equation. And we're going to go ahead and use this equation to start graphing it out. So the center of the equation, as we learned from the practices we've had all year long, is that we want to go ahead and do the opposite sign. So the center is going to become 8, comma, negative 7, right? So we have is 8, comma, negative 7. So here we go. 8, comma, negative 7, somewhere around here is going to be the center. Okay, so that's my center. And then from there, we're going to go 9 spaces to the left and to the right. I'm not going to have enough space on this right here. So we'll try it out as much as possible. So then we have then is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 1. And I don't think I'm going to have enough on this one. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be a large circle, that's why. And then go in the opposite direction, you would go on the x-axis 9. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's about here. And then you would normally go as the opposite direction, 9 spaces out this way as well. So you should get a nice circle when we do this right here. And eventually it's going to come out this way, somewhere on here. And then we'll connect these guys right here. And it should be a nice circle shape. So try to make a nice circle right there. Okay? Now, when you have a circle, as we mentioned, we will not have as a foci nor the vertices, because the length is going to be exactly the same on both sides right there. Okay? So you don't have to worry about that. All right. Now, let's go ahead and do the next one. So the next one right here, we're going to go ahead and do, again, completing the square right here. So we want to group all the x's. So it's 4x squared. And let's see, plus 24x. That's 1 right there. And then for the y, we have is plus y squared minus 2y, right? 2y, yes, equals negative 21. So the 21 is going to come to the other side. Okay, so now we're going to take half of this. So when we have the number 4 right here, coefficient, I got to actually factor it out before I do that. So let's go ahead and continue to do some more work to this. So 4 times 6 is 24, right? So plus y squared. This one's okay. Oops. It's okay because there is no coefficient for that one. So we're good with that one. Okay. So now we're ready to do half of that b squared. So half of 6 is 3. So that's going to be 3 squared right here. So again, it cannot have a coefficient right here. In order to do this on completing the square, you have to factor it out on that. And so then this one's okay. So we have is y squared minus 2y, and then half of 2 is 1. So 1 squared is equal to negative 21. And then we do on the other side. Now, again, this is the important part. When you do the other side, because the 4 is out here, and when I distribute this, this should go back to the original, which is over here. So this is a man-made number right here. So we have to include that when we put it over here. So it's 4 times 3 squared. And then on this side right here, we don't have to worry about that because there is no coefficient. So it's just plus 1 squared right here. So then we clean this up. We have this 4 perfect square. We have this x plus 3, right, squared. And then we have this plus y minus 1 squared is equal to, and then we have to work that out. So let's see, negative 21 plus 4 times 3 squared plus 1 should give us about 16. So 16 is right there. So again, we can't have 16 by itself out here because we want to equal to 1. So we want to divide everything out by 16 on both sides right here. Divide by 16. So this equals to 1, which we want right there. This right here, we can't reduce it, so we keep it the way it is, squared over 16. But on this one right here, I can reduce it because 4 goes into 16 4 times. So then I have is x plus 3 squared all over 4 right there. Okay, so we just need to take it one more step, which is then square rooting it. So that will help us then get the numbers for that. So that's 2 squared, and then plus y minus 1 squared all over 4 squared is equal to 1. So that's your final answer right there. So once I get here, now I'm ready to draw the graph out. So the center of this is the opposite. So we have is negative 3, positive 1. So center, oh, I didn't set this one up. Okay, so center is negative 3, positive 1. So a negative 3, positive 1. So there's my center. And then from the center, I'm going to go 2 spaces to the left and 2 spaces to the right because that's on the x-axis right here. So 2 spaces to the left, 1, 2. 2 spaces to the right, 1, 2. And then we're going to go, 4 spaces up and down. So 1, 2, 3, 4. And then 4 spaces up and down. So 1, 2, 3, 4 right there. So now we're ready to graph it out. So again, this is the ellipse because one side is larger than the other side. So if this is an ellipse, then I need the foci. So the foci says the largest side. So it's obviously this one right here, 16. So 16 minus 4 should give us about 12. And square root of 12 is going to give us about 3 point something. I believe it's 3.5-ish. So we're going to go with 3.5. So whatever's the longest side, because remember, if I go 1, 2 right here and tried, oops, 2 out here. 1, 2, I can't go 3.5, so it has to be up here where it's going to be 1, 2, 3.5. So it's really, really close to that part right there. And then it's going to go 1, 2, 3.5, which is really, really close to this. So the coordinates of that is going to be, where is this? -3. So -3 and 3.5 more from, what was it, 1? So that should be 4.5. And then the other one should be -3 and 3.5. And then 1 less from that. So it should be what, 2.5? So around there, -2.5. So that's going to be, yeah, about -2.5, because that's your -2 and -2.5 right there. So then the vertices, which is then the tips of those, is going to become same thing, -3, and then the tip of this we said was going to go up 4 spaces. So 4 spaces up from 1 should give us the 5, and 4 spaces down from the 1 should give us, I believe, the 3, right? So -3. Okay, so that's going to be your final answers for those. So things that we will add onto it from what we had on the last section on the parabola.